In this video, I'm going to cover some problems involving the union, intersection, and complement of independent events. Okay, so the only reason I'm going to be able to use the formula that I'm going to use is that we're assuming that these events are independent. Okay, it's going to be a completely different story if we're looking at dependent events, but in these problems, these are all looking at independent events. Another way where we've done these problems before is a Venn diagram, and that's what I'm going to show for each of these before I actually calculate the probabilities. All right, so again, it states in the very first sentence, events A and B are independent. Okay, so what do we know if two events are independent? Well, we know that the probability of events A and B happening is equal to the probability of A times the probability of B. Okay, and this is only the case if we're looking at independent events. If we're looking at dependent events, we have to get into some conditional probability. We haven't talked about that yet. Okay, so if we know that, then if we're looking on a Venn diagram, when you think of the intersection of two events, if we have event A and we have event B, the intersection of those events is the overlap. So if we're trying to find the probability of the overlap, all we do is multiply the probability of event A times the probability of event B. Okay, so let's go ahead see if we can first figure out the Venn diagram, and then based on these numbers that they gave us, so that the probability of event A is 0.51, B is 0.81, and based on this formula that we know, let's see if we can't calculate these two different probabilities. So we'll start with A. So we'll do that over here, and then we'll do B over here. So we have two separate problems here. So we're going to have two separate sample spaces. Okay, so in event A, it says compute the probability that neither the event A nor the event B occurs. Okay, so that's saying A does not occur, and at the same time, B is not occurring. Okay, so if we have event A here, and we're going to go over here, and we have our event B. So again, it's saying that neither event A or event B occurs. Okay, so that's saying that event A cannot occur and event B cannot occur. Well, the only space where A and B are both not occurring is outside of our circles. Okay? And so this is an example of where we're going to have to use the complement to be able to figure this out, because the only thing we know is the probability of each of these circles, and then we can figure out the probability of this space in between. Okay, so let's go ahead and do that then. So we have to figure out first how much space is in this kind of white area. Well, this is equal to the probability of A. This is equal to the probability of B. But we have this overlapping part. So if we just added the probability of A and the probability of B together, well, we would be including this overlapping part twice. So we don't want to do that. We only want to include it once. So this is where we're going to have to do the probability. If we want to find this total white area, we're going to have to do the probability of A plus the probability of B, but then we're going to have to subtract the probability of that overlap, where the A and the B together. And now that we know this formula, it's not too hard. We're just doing the probability of A plus the probability of B minus the probability of A times the probability of B. Okay, so let's go ahead and do that real quick, and we'll find this answer. So my calculator out. Probability of A is 0.51. The probability of B is 0.81. But then we need to subtract probability of A times the probability of B. And in this case, we get 0.9069. So this is equal to 0.9069. And that would be great if we were trying to find the area of the region that was not shaded, but that's not what we're trying to find. We're trying to find the area or the probability of the region that is shaded. So this is where we have to use that complement. If we're trying to find the opposite probability, we do 1 minus that probability. So 1 minus 0.9069. Again, we can just go to our calculator. 1 minus 0.9069 is equal to 0.0931. And I believe it wants you, does it want you to round at all? I guess it does not want you to round. So in this case, we would put our 0.9031. And that would be our probability. Okay. All right. So let's look at B. So again, this was an intersection problem because we were finding that it had to be both. It could not be either A or B. So A and B couldn't be. Okay, now let's look at the second one there. So this one says compute the probability that A occurs but B does not occur. Or, sorry, not but. It says A occurs or B does not occur or both. So this is a union problem. So we're trying to find the probability that either A doesn't occur, B doesn't occur, or both of them don't occur. Okay? Well, let's think about this first. We're kind of shading all the area where A is not occurring. That's everything that's not in A. Now remember, that overlapping region is in A, so we're not shading that. And then same thing goes with B, so anything that's not in B, well, that's everything over here except the overlapping region. So what you should notice is that if it's one or the other, or both, it is everything except our overlapping region. Okay? So everything is going to be shaded except the overlapping region in this problem. So if we're going to do that, well, if we have to find the probability of the overlapping region and then just do 1 minus that. So if we're finding the probability of the overlapping region, that's A times B. So that's 0.51 times 0.81. And then we're going to do 1 minus that. So the final probability will be 1 minus 0.51 times 0.81. So I can do that in my calculator all at one time. So if I do 1 minus 0.51 times 0.81, we get 0.5869. The answer for this one, part B, would be 0.5869. Okay, so hopefully those examples helped you out there. If you need more help, remember I am here in this class right now. I can help you maybe fill in a Venn diagram or find the formula for your specific problem. But if you know this formula right here and you know how to find the probability of a complement, then you should be able to do these problems.